Hello everyone, I am Dr. Malati, working in as a SR University Associate Professor in ECE Department. Today's video lecture is on buses. So buses means data transferring media. So there are two types, synchronous data transfer and asynchronous data transfer. Synchronous data transfer we have already seen in the previous video. So now in this lecture I am going to talk about the asynchronous data transfer, interface circuits and then standard I/O interface. It is a technique to manage transfer of data between CPU and external devices. External devices means they are peripheral devices, otherwise called as input-output devices. Data transfer at an unpredictable rate with no fixed timing or synchronization between the CPU and external devices. So here unpredictable rate. So asynchronous means there will not be any usage of clock. So synchronous means we have to use clock signal to synchronize the sender and receiver. But in this case, asynchronous mode, there is no such clock. So data transfer will happen in an unpredictable rate. So processor speed different, I/O devices speed different, with no fixed timing. Definitely time cannot be fixed because CPU is fast. I/O are very slow. Therefore, no fixed timing or synchronization between CPU and external devices. So they will not operate in coordination with one another. No clock signal is used. It is used in situations where data transfer rates are variable or unpredictable, such as in serial communication or with slow devices. So slow devices we know CPU is fast and other I/O devices are very slow. Serial communication means CPU operates the bits in parallel form, but I/O devices will operate the data in serial form, and then data transfer rates are variable. So since the speed is variable, data transfer rate is also variable. What is data transfer? Data transfer rate, it is equal to the number of bits transferred for one clock cycle, one clock period. To manage transfer of data in asynchronous mode, so definitely external force has to be applied to manage the asynchronous data transfer, because in case of synchronous, clock is enough to manage everything. The CPU uses interrupt driven I/O. So instead of clock in synchronous mode, we are using interrupt driven I/O in asynchronous mode, where it waits for an interrupt signal from the device to indicate the data is ready for transfer. So any I/O device which needs to transfer the data, it has to send interrupt driven I/O, that is interrupt signal, which mentions that the device is ready for data transfer, and CPU can then initiate. So once if CPU recognizes the signal, it initiates the transfer of data, and the device will send data back in an asynchronous mode. So after acknowledging that initiation, the device will transfer the data. Asynchronous transfer is a form of input-output processing that allows other devices to do processing before the transmission or data transfer is done. So in this case, asynchronous transfer mode, it is a form of I/O processing. It allows other devices also to do the same processing before the transmission or data transfer is done. Before the completion of data transfer, it is possible for the other devices to send their data. Problem faced here, it is not sure that the data on the data bus is fresh as time is not fixed. Anytime the data will pass through, we cannot sure that we are not sure that the data available in the data bus, it is fresh, it is new, otherwise it is old. So whether it is new or old, we are not sure. So that is the problem in this case. This problem is solved by the following mechanism. So only thing we should know, the data is correct or not. If it is new, I mean updated, then it is correct. If it is old, already available in the database, then it belongs to wrong data. So we must know, we must be sure that the available data is correct. For that, we are having two mechanisms to identify the data which is correct. Strobe mechanism. Strobe is nothing but a signal. Handshaking mechanism. First one strobe mechanism. Second one handshaking mechanism. Data is transferred from source to destination through data bus in between. So, in between two devices, buses are available. The bus is carrying data, therefore that is named as data bus. And here two devices means one device is having the data to transfer to the another device. So which one is ready to send the data, that device is named as source, and which device is taking the data, it is known as destination. Here number one, strobe mechanism. So in the strobe mechanism, there are two cases. Number one, source initiated strobe, and number two, destination initiated strobe. So in these two cases, how the signal is getting started to initiate the data transfer. First one, source initiated strobe. See, in this diagram, source is having the data. It has to put the data on data bus, and it is the destination. So it has to send the data means initially it has to make the strobe signal on. Then it is putting the valid data on the data bus. So after that, it is the function of destination to get the all data, to get the available data from the data bus. Source puts the, so this mechanism is explained in three steps. Number one, source puts data on the data bus because it is having the available data to destination, and then it is making the stored signal on. And second step, destination on seeing the on signal of the strobe. So it is continuously watching, and whenever it recognizes the on signal in the line, then it is ready to read the data available on the data bus. After third step, after reading data from the data bus by destination, strobe gets off. So automatically strobe signal comes down and it is readily available for the next data transfer by the source to destination. And away, and this is represented in terms of signal. So first one, strobe signal is to be sent by the source to destination. So it has then data bus, in the data bus valid data is available. So I'm sorry, first one, the source has to put the data in the data bus. So valid data is kept in the data bus. After keeping the data, the source informs the destination through the availability of the strobe signal on the line. So first it keeps the data and then it sends the strobe signal to destination. It shows that first data is put on the data bus, then strobe signal gets active. Second one, destination initiated signal. So destination, it is having the data to transfer to source. So what it has to do? It has to initiate the data transfer. For that, this diagram shows it is destination. Destination is sending the data. So it is indicating destination wants the data, therefore it is sending the strobe signal to source and then source gives the data on the data bus. So this operation is performed in 3 steps. Number 1, destination on the strobe signal to ensure the source to put the fresh data on the data bus. So in the previous case, what is the data, the direction is from source to destination, but the direction of strobe signal is different. So by this, what is the meaning? In the first case, source voluntarily gives the data to destination, but in the second case, destination is asking for the data to send. So source compulsorily sends means it has to initiate the strobe signal on. But if in the second case destination wants data means it has to initiate the strobe signal, then source gives the data in the data bus. That is what the difference. So data from the source to destination, there is no change in it. But who initiates? Who wants? So voluntarily source gives means source has to give the strobe signal. Destination wants this data from source means destination has to initiate the strobe signal. That is what shown in the diagram. So first point, destination on the strobe signal to ensure the source to put the fresh data, that means valid data on the data bus. Second one, source on seeing the on signal, it is ready to put the fresh data on the data bus. And third step, destination reads the data from the data bus and strobe signal goes off. So it is readily available for the next source to data, next source to destination data transfer. So next one. So here in the previous case, first valid data, second strobe. But in this case, first strobe, second valid data. This is what the difference between the two cases. So it shows the first strobe signal is active. Then the data is put on the data bus. Problems faced in strobe-based asynchronous transfer. What are they? In source-initiated strobe, it is assumed that destination has read the data from the data bus, but there is no surety. So in the source initiation, first one it will keep the data first, second strobe signal. So the activating strobe signal is delayed by some time duration from the data. So starting data and the strobe signal starts delayed by some amount of time. So during that time, what is the data available? Will it reach to the destination? We are not sure. The destination correctly got the available data. It is not sure. And in case of destination initiated strobe, it is assumed that source has put the data on the data bus, but there is no surety. So in the destination initiated strobe, so first one it is asking for the data. So first it is giving the signal, then only it is giving the data. So if the data given is delayed from the active signal by some certain amount of time. So full data the source has put on the data bus, it is not sure. Full available data it has put, it is not sure. So partially maybe, may not be, that we are not sure. Next one, source initiated. So first the problem is solved by first one strobe signal and the second one handshaking. So what are the types in handshaking? First, source initiated handshaking. So in the case of strobe signal, we have two cases. First one source initiated, second one destination initiated. In the same way, handshaking also, source initiated handshaking, second one destination initiated handshaking. In the first case, when the source initiates the data transfer process, it consists of data valid signal. First one data valid signal and second one data accepted signal. So what is data valid signal? If the data valid signal is on, it tells data on the data bus is valid, otherwise invalid. Once if the data valid signal is on, during that time only available data is valid. Data accepted signal means if it is on, it tells that data is accepted. If it is not on, it is not sure that the data is accepted by the destination. Once if it is on, it makes sure that the destination accepted all the data. See that timing diagram, data bus, the whole is valid data. So on signal, valid data. Data is valid. So almost all the part is covered by the data valid signal, so that the data is valid. And then data accepted. So first one it is initiating, later the destination is ready to accept all the data. If all the data is accepted, then it will send the signal data accepted signal. So this will happen in the for 5 stages. Number one, source places data on the data bus and enable the data valid signal. First it puts the data because it is readily having the data, so it keeps on the data bus. After keeping the data, it is immediately telling that the data is valid. So data valid signal it is sending. So first step it is keeping the data on data bus. Second one, immediately it is sending the data valid signal, and then destination accepts the data from the data bus and enable the data accepted signal. So after accepting all data, the destination sends the data accepted signal. The same diagram is repeated here to refer. And then after this, disable data valid signal. So once if work is done, it cannot be left as it is. It should be disabled. So whenever necessary, the signal is enabled, the signal is getting on. At the same time, after completion of every work, the signal should come down so that it will facilitate the other operations to continue. That is why these two signals have to come down. That means from on state to on state. They should come to off state. So after this, disable data valid signal means data on the data bus is invalid. Now no more it is effective for destination to get it again and again. Next one, disable data accepted signal because already acceptance over. So the signal has to come down. And now there is surety that destination has read the data because accepted data is sent by the destination. So it makes sure that the destination has taken the data correctly, fully accepted. Data from the data bus to the data accepted signal. So signals can be seen as it shows that first data is put on the bus. So whoever is having the data, it should be kept on bus first. Then the data valid signal is activated. Then data accepted signal comes to on stage. After accepting data, first data valid signal is removed and then data accepted signal will be removed. So second one, destination initiated handshaking. When destination initiates the process of data transfer, what are the required signals? Request for data. So same only. Once the source is having it compulsorily giving means it has to initiate. But the destination wants the signal from source means it has to initiate. So that is for that the signal names are different. So in this case, request for data. If on request for putting the data on the data bus. So it is asking the source to put the data on the data bus. See here, source, destination gives request for data. You put the data on the data bus, that is the request. And then data valid. So data valid means immediately source will put the data on the data bus. After that it will send second signal to indicate that the data available is valid now. So here if it is on, tells data is valid on the data bus. Otherwise, if it is off, if data valid signal is off, the data it becomes invalid. If it is on, the data is valid. So now the same thing is repeated. The diagram is repeated, and what is happening? What is happening? First one, when destination is ready to receive data, request for data signal. Request for data signal. Source in response puts data. Immediately available data is put on the data bus and then enable the data valid signal. So to indicate that the data available is now valid. Then destination accepts data from the data bus, and after accepting data, so after completing the work, these signals should not be left as it is. They should come down for the purpose of other operation. Immediately disable request for data signal. It only initiate a request for data. So it has to bring the data, the request for data signal to 0. So first one it will bring down, and then data valid signal will become disabled. If it is off, it automatically states that data becomes invalid. So repeatedly obtaining that available data is meaningless. So there is no more valid data. Now there is surety that source has put the data on the data bus through data valid signal. Next one, it shows that, so the diagram shows that first request for data signal gets active. So destination initiated. Then data is put on the data bus. Then data valid signal gets active. Then after reading data, first request for data signal is getting off. Then data valid signal goes down. Features. So for all these two as a problem solution will happen using the callback function. Now, what is callback function? It is called back. So, the function is called by the device driver. So the function is called by device driver when data transfer operation is completed. So whenever the CPU is performing the main task, in between data transfer is required, the interrupt is happen. So for that interrupt, the calling function is callback function is given. So callback function is started means data transfer started, and data transfer is completed, then immediately the callback function is to be called, and it allows the CPU to do further operation. So it indicates CPU that data transfer is completed. It is finished. See, once the operation is completed, the device driver calls the callback function. So first one it is generated, given, and after completion it is calling back the function so that it notifies the CPU that data transfer is finished. Next one, this is also the interrupts. So I already told data transfer is an interrupt only. By indicating the interrupt, it starts. By calling back, it is showing that the function is completed, the transfer is completed. Interrupt are signals sent by the I/O devices to the CPU to indicate that an event has occurred. In the case of asynchronous I/O, interrupts can be used to signal the CPU that data transfer operation has completed. If clock is available, then no need to indicate the starting and stopping. But it is asynchronous. That is why. So when it is starting, the CPU does not know. When the transfer is ending, this also does CPU does not know. So it has to be indicated, informed to the CPU. That is what here interrupt signal. When an interrupt occurs, CPU starts executing the main task or current task and transfers control to an ISR. So already we have seen in the previous videos that interrupt means for specific task. It may be input task, otherwise output task such as print, otherwise memory data transfer. Here we are seeing the data transfer. So data transfer function means the control will transfer to interrupt service routine, IS interrupt service routine, that is ISR, specifically written for the data transfer, and it is stored in particular memory location. So once if it is known that the data transfer interrupt, immediately that corresponding memory address to which the control is transferred. Next one, control. When an interrupt occurs, CPU stops the current and transfers control to an ISR that is responsible for handling the interrupt. Here the interrupt is for data transfer. And then polling. So polling is a technique because nowadays there are multiple processing system, multiple processors, so that so many IO devices may be connected. Which IO devices is asking for the data transfer? He does not know. CPU does not know. That is why polling technique is used. Polling is a technique used to check the status of the device periodically. So, within certain duration of time, it has to repeatedly ask the IO device to determine if it has completed the data transfer operation, because interrupt has already occurred. Transfer is also started. When it is ending, since it is asynchronous, processor speed more, IO device is less, so may be delayed. Even though we know the speed of the CPU, the operation speed we do not know, because IO are very slow in speed. So it has to be indicated back. So how it is indicated means CPU periodically is asking whether the data transfer is completed or not. With asynchronous IO, CPU can hold the device periodically to check if the data transfer is finished. If it is complete, then CPU can retrieve the data from the device. And next one, select function. So as I have told you already that multiple devices, which device is called for that select function is used. With synchronous IO, the select function can be used to monitor the status of the device which is asking for the CPU. For that select function is used for specific IO devices, because so many IO devices are connected to so many processors. Here multiple processors, multiple IO devices, so that select function will be used for the corresponding IO device to get notice the end of the data transfer. Next one, advantage of the data asynchronous data transfer. Flexibility. So it is adapting. So we should not think that always synchronous is best. Asynchronous is adapting. It is flexible to the variable situations. So it allows for flexible data transfer rate, and can adapt to varying transfer speed without the need for synchronization. That means without the necessity of clock. This is particularly useful when dealing with the slow or intermittent devices. Very slow. Already I was slow only. But suppose in between intermittent devices are coming into C. So at that time, the asynchronous will take care more. And then next feature, resource efficiency. That because data transfer is not synchronized to clock signal, asynchronous data transfer can be more resource efficient. So available resource will not get wasted. It can reduce the overhead of synchronization. So overhead of synchronization means for giving synchronization we need to add additional bits, sync pulses. That is, but in this case there is no clock, so no additional bits. The additional bit means it is overhead only. So we are reducing the overhead and improve the utilization of system resources. So whatever the available time, whenever it is idle, that resources will be used. Whenever it is busy, that will be indicated accordingly and will not wait for that device, and it will go to the main task and continue to do. And then reduced latency. So once again I am telling, it will not wait. Therefore there is no delay. Reduced latency. Delay will be reduced. It can help reduce latency or delay between the initiation of data transfer and its completion. So CPU does not have to wait for the completion of the data transfer. It will start and goes to the main program. When it takes and come back, and then it takes charges of the buses and other resources. It can improve the responsiveness and overall performance of the system. So CPU does not become idle, does not wait. Therefore, automatically performance will be increased. And better error handling. It can provide better handling, better error handling, as it allows for the detection and handling of errors. So, in case of asynchronous, this is a big advantage, because error detection and error correction, error handling capacity will be more for the asynchronous mode of transfer, and this can help ensure that data is transferred accurately and reliably. There is no error means accurate. Accurate means reliable. See, no need to repeat the transmission. Compatibility. It is compatible with a wide range of devices and systems, because multiple systems we are using. That is why it is compatible. Wide range of systems, making it flexible for the technique for managing the data transfer. So whatever the data transfer be, it can able to, it is able to handle, it is able to manage. And then disadvantage of asynchronous data transfer. First one, complexity. So more complex, as it requires interrupt driven in IO. In the ISR is needed. That is why it is complex, because ISR is completely separate from the main program and other techniques to manage the data transfer. And then overhead. Already I told you no overhead, but here overhead means CPU must constantly monitor. So reducing the CPU work, at the same time increasing the CPU work, because automatically it has to monitor the IO devices whether they have completed the data transfer. So interrogating, polling, it is also another extra work for the CPU. So it is also the overhead. Extra work means it is almost equal to overhead. So it can also introduce additional latency. And more work means more delay, more time. More time means delay. So after all data transfer, because our ultimate aim is to not to spend much more time in data transfer. Other task the computer, the CPU has to perform. So for time taken is more for data transfer, automatically the performance will come down. Then synchronization is an issue. No clock, so automatically slow running devices like IO, high-speed processor like high-speed processor, both will always, we cannot expect that they will coordinate with each other always. But to when dealing with multiple devices or large data transfer, small volume of data means okay, no problem. But a large volume of data transfer means it is too fast, it is too slow. So automatically it will create some complexity. Then compatibility issues. It may not be compatible with all devices and systems. So system means CPU, all CPU. So each and every I/O device is slow, okay. But if it is a defined speed, then every problem will be solved easily. But every device will have their own speed, so it is not uniform. Even slow, okay, slow speed, it is not uniform for all I/O devices. Every device will have their own speed, so speed will be different for different I/O devices. So to managing that also will become difficult. And then interface circuits. Interface circuit is a mediator between I/O device and the system, I/O device and the CPU. So every component or module of the computer has its distinct capabilities and processing speed. So processor means it will have several components like a keyboard, printer, memory, so much of modules will be available inside the computer box. But all those components speed will not be equal to the processor speed. The component speed also will be different for different components. It depends. For example, the processing speed of the CPU is much higher than the other components of the computer, such as keyboard, display. So keyboard speed is different, display speed is different, CPU speed is different, but more speed. It is very fastest. So we need a mediator to make the computer communicate with the I/O module. So if we have a mediator circuit in between, it will computer CPU will feel comfortable in transferring the data between the I/O device and CPU itself. This mediator is referred to as the interface circuit. So interface will be adaptable for the whatever data comes in and whatever the data output device needs. The same format it is able to provide. That is why we are using the interface circuits to match the property of the processor and other I/O devices. One end of the interface circuit is connected to the processor through the bus lines. And what are the lines? Address line, data line, and then control line. These three are the bus lines. Next one. So that diagram is shown here. This is the interface. This is the interface, I/O interface. One end is connected to the input or output device, and another end is connected to the buses of the CPU. So first one, address line, it is connected to the address decoder. Second one, control line, it is connected to the control unit. Third one, data line, it is connected to the data status control. So these three are the registers inside the I/O interface. So I/O interface consists of number one, address decoder, number two, control unit, and number three, registers. In that registers also there are three types. Number one, data, status, and control. So first one, address is decoder. So address decoder means it has to decode the address to identify the service needed by the I/O. Which device is calling the uh, function. I mean service. The address line is decoded by the interface circuit to determine if the processor has addressed this particular particular IO device or not. So based on the decoded address, it is able to, processor is able to recognize which device is calling it. And second one, control line is decoded to identify which kind of operation. So read or write operation. Which kind of operation means read operation or write operation. That means it is the direction in which the data must flow. And then data is used to transfer the data between IO and the processor. The other side of the interface has the connections that are essential to transfer the data between IO interface circuit and IO device. And this side of the IO interface is referred to as the port. So ports are the pins through which the IO devices are connected to. And the port of the IO devices can be parallel port or serial port. Both are, that is, IO interface circuit is adaptable to handle the serial as well as parallel, serial data as well as parallel data. The interface circuit has a data register that stores the data temporarily while the data is being exchanged between IO and the processor. So, the data register is able to store the data temporarily because it is to be transferred to. That is why it is temporarily we are telling that word. The interface circuit is also the status register. So status register, bits of the status register indicate the processor whether IO device is set for the transmission or not, whether the device is ready or not, ready for transfer or not. That is status. And then interface circuit also has control register. The control register type of operation, read or write. Already I told you, registered by the processor to read or write. So control means read or write. Data means the direction of data flow. Status means whether the device has completed the transfer or not. That is the status. And next one, the interface has also address decoding circuitry which decodes the address. Address will be sent in hexadecimal, but it has to decode and understand which device over the address line to determine whether it is being addressed by the processor, correct address or not. The interface circuitry also generates a timing signal that synchronizes the operation between processor and IO devices. This is because of the feed mismatch. And the interface circuit is also responsible for the format conversion that is essential for exchanging data between processor and IO interface. This format conversion, which we will see in the next slide. So first one, parallel port and the serial port of the IO interface circuit. So there are ports through which the IO devices are connected through the interface circuit to the processor, I have told. So now we have to talk about these ports. These ports are categorized as serial ports and parallel ports. So first, parallel port. To understand the interface circuit with the parallel port, we will take the example of two IO devices. First one, we will study an input device, that is keyboard, that has 8-bit input port, and then output device, that is a display which is also an 8-bit output port. Here multiple bits are transferred at once. So if we press A from the keyboard, this will be transmitted as ASCII code in terms of 8-bit. In the same way, it has to be the same A word has to be displayed in the display unit. It has to be sent through 8-bit only. So it is accepting 8-bit, and in the keyboard also it is giving the 8-bit input. So all the bits, all the characters are 8-bit only. That is the parallel code. So sending 8 bits simultaneously means we need to have 8 lines, 8 parallel lines. Then only 8 bits corresponding to the character will be sent simultaneously. One by one it is not possible. The encoder then outputs 1 byte of, so 8-bit means 1 byte, 1 byte of data along with 1 valid bit. So what is that 1 valid bit? The valid bit changes its status from 0 to 1 when the key is pressed. So 0, when the key is pressed means data has to be sent. So it is changing from 0 to 1. 1 means data is flowing. So when the valid bit is 1, the ASCII code of the corresponding character is loaded into keyboard data register or the input interface circuit. So input means keyboard. Keyboard data register means it is accepting the character. All 8 bits are the corresponding character pressed through the keyboard. That is what the meaning. And then now when the data is loaded into the keyboard data register, the KIN, keyboard in status flag present in keyboard status register is set to 1. So already I have told, if it is 1, it is ready to accept, it is ready to store all the 8-bit corresponding to the character pressed in the keyboard. It causes the processor to read the data from keyboard data. So it is available in keyboard data. Once the processor reads the data from keyboard data register and then KIN flag comes to 0. So KIN, this is the valid bit, changes from 0 to 1. So if it is 1 means all data, all 8-bit data is available in keyboard data register. So KIN flag is available in keyboard status register and it is coming to 0 means all the data are read by the processor. Next one, here the input interface is connected to the processor using asynchronous bus. Okay. So the way they alert each other is using the master ready line and slave ready line. These two ready lines we will see in the next diagram, in the next slide. Whenever the processor is ready to accept the data, it activates master, because here processor is assumed to be master, so it activates the master ready line. And whenever the interface is ready with the data to transmit to the processor, it activates the slave ready line, because this interface has to take the data from slave and then it has to give it to the master ready. That is why interface is ready with the data to transmit to the processor. It activates its slave ready line. The bus connecting processor and interface has one more control, that is read-write. So read means reading the data, write means writing the data, overwriting the previous content. Is set to 1 for reading. So R bar W is equal to 1 means read. If it is 0, then it indicates that write operation. So for the input port we have seen, for the output port we have a diagram to explain all the details. Observe the output interface shown in the figure below that connects the display and the processor. So output unit is nothing but display unit, because it shows the results or data in the display to the user. This display device uses two handshake signals that are ready and new data and the other master and slave. Master and slave ready signals. Master and slave ready signals. Master ready and slave ready. So read write data based on the address of the device. Data is sent and display data. So whatever the data is sent, it has to go to the display data register, and display data register will show that it is available in the data means 1, it is already going to the display means 0. So that is data is going to the display unit and ready signal it will send to this interface asking for the letter to take in and new data. If the data is displayed, then it will indicate that whatever the data is available in this register is displayed, that task is over. Now new data I am ready to take. This is what the meaning. So parallel output code that connect the display and processor. Next one, when the display unit is so from the previous diagram, it is explained as statement in statement. When the display unit is ready to display a character, it activates its ready line to 1. So I am ready to get the data. Which sets up D out flag in the data status to 1. So I am ready means the out flag in the data status register should be equal to 1. It is made equal to 1, and then the processor places the character to the display data register. It is display D out display status register. It is display data register. Whatever the data to be displayed will be available in the data register by the processor. The processor puts the data. As soon as the processor loads the character in display data, the data out flag sets to 0 and the new data line to 0, because what is happening here, processor puts the data to be displayed and the status is equal to 1, and the display unit takes the data and displayed. Now it has to make the status flag to 0, then only it will be ready to take new character for the display. That is why it will come to 0 and the new data line to 1. Now, as the display senses the new data line is activated, it turns the ready line to 0 and accepts the character in the display data register to display it. And then, so till now we have seen the parallel port. Now we go for serial port. The serial port connects the processor to device that transmit one bit by one bit. So previously 8 bit at a time, but here 1 bit. So the connecting bus is only one. We require only one bus. In the previous case, 8 buses we need. Here on the device side, the data is transferred in the big serial pattern, and on the processor side, the data is transferred in big parallel pattern. This is how it is happening in the next diagram I will show. So processor will handle the data parallelly, but IO devices will handle the data serially. That is why processor is speed, the speed is more, but serial IO, input output devices are very slow because they are handling the bits one by one. That is why very slow. The transformation of the format from serial to parallel, that is from device to processor, and from parallel to serial, that is from processor to device, is made possible with the help of shift registers. So In case of the input shift register, it will get the serial input from the IO device and convert it into parallel form. These parallel bits are going to processor. In the same way, processor, after completing the operation, it will give the output in parallel form. So, in the output side, the shift register will get the output in parallel form from the processor and convert from parallel to serial, and the serial form output will be given to the IO devices. So this is what the interface circuit. So here see input data input serial input from the input output devices. So input shift register, it is converting the serial input to parallel output. This output will go into the data in register, from which all data will go to the processor through the data lines. Almost it is 8-bit lines. So data from D0 to D8, all data bits are transferred in parallel form, and then here after performing the task, the data will come out. I mean, the processor will send the output in terms of in parallel format. So in the output stage, the data out register will get all the 8 bits in parallel form, and all the 8 bits are given to the output shift register, which is able to shift the parallel bits into serial bits, which will be taken by the input output devices. So for this controlling units, status and control unit, receiving clock, transmission clock, interrupt, and here chip and register select. So it is my address. That means IO devices will give their address. Register select 1, RS0, read or write operation, ready signal, accept signal. So accept signal is going out. The ready signal is given in. Read write operation, all are the same direction in which it is given to the interface. Chip and register select. So this is the serial interface circuit. So shift register plays an important role in converting the parallel format to serial format or serial format to parallel format. In this way, we are overcoming the speed difference for the input-output devices and processors. So with this, we conclude this lecture. We will see in the next. Thank you.